Okay, fuses and circuit breakers. Well, fuses basically are thin pieces of metal that melt if the current is too high. A circuit breaker, sometimes known as RCCBs or residual current circuit breakers, they are devices that monitor the difference between the live wire and neutral wire, and if the current goes too high all of a sudden, it will actually switch off. It will break the live wire. If it notices a sudden quick change between the live and neutral, it will actually change the it will disconnect the live, making it safe. How does a fuse work? Well, it's a bit like thinking this. Imagine electrons going on a journey, and then what you do is you put a deliberate weak spot in the circuit. In this case, it could be like a bridge, and obviously the more electrons you have on there, eventually the bridge will break, and then of course the electrons can no longer move. And that's what a fuse does. Basically, it breaks, and then you have to replace it with another fuse. Here's an example of how it may happen. You can see here a kettle, and if you notice, I've got a live wire and a neutral wire going in. The live wire carries in the energy towards the it supplies energy towards the heating element. It's a bit more complicated than that, but you don't need to know that for GCSE. There's a fuse on the live wire, as you'd expect. Let's imagine that the live wire, as you probably know, some wires tend to fray. They tend to sort of get broken, a bit like, mobile phone wires will sometimes break away, which is really, really frustrating. Now, those mobile phone wires have got low voltages. These wires have got high voltages and big currents that can easily kill. And if this live wire touched the metal case, it would make the whole kettle live. And then if you touch that, you could be electrocuted, and it would obviously have catastrophic consequences. So you'll find that all metal containers will have an earth cable attached to the metal case, like you see here. The earth cable, which you saw inside the plug, goes onto the metal case inside of it, and if you follow it all the way back through the plug, through the socket into the wall, you find it goes into a connection underground. So that, let me explain what happens now. The live wire touches the metal case. The electrons, the current, rather than go through the heating element, find it a lot easier to go through the metal case, through the earth wire, down to the ground. Suddenly there'll be a massive amount of current doing that, because that's actually dead easy to do that. There's low resistance there. It's very easy to do it. So there'll be a really, really big current, and of course then the current will then blow the fuse. If the fuse is blown, then there's no electricity being supplied to the kettle, and the kettle is safe. What you mustn't do is, well, if you put another fuse in exactly the same size, it will blow again. And at that point, you've got a bit of a problem there. Whatever you do not put too big a fuse in there, because that too big a fuse may not melt, and you may end up still having a live cable as well. So be very careful of that. And there you can see exactly what's happened there, that the fuse has blown because the current went through the metal case, through the earth, and into the ground. If you've got a plastic kettle or any device that's made of plastic, you do not tend to need an earth wire, because if the live wire did touch the outside of the plastic case, well, it's insulated already. The electricity cannot go through the plastic. And those are known as double insulated devices. So double insulated devices, I've got a stereo, for example, that's made entirely of plastic, the outside, and there's only two wires going into it. There's no earth. There's no need to, because if the live wire did touch the metal, did touch the plastic case, it wouldn't do any damage to you. Right, also, of course, you need to know that the earth is attached to the metal cases. Right, to work out what sort of fuse to use, you need to use this formula, which is power equals voltage times current. Power is in watts, voltage is in current, voltage is in volts, or potential differences in volts, and current is in amps. And if you rearrange that formula, you're able to work out what fuse it is. So, for example, here's a good example. A 2000 watt kettle runs on 230 volts. What current does it use? What fuse should be fitted? And I've quickly worked it out there. The current is power divided by voltage. It comes at 8.7 amps. So really you want to stick a fuse higher than 8.7 amps. If you stick a 5 amp fuse in there, it'll blow automatically because it's used to working on 8.7 amps. So for that, you'd stick a 13 amp fuse in there. That's the standard size you get in the UK. 1, 2, 3, 5, and 13 amps tends to be the size of the fuse you get in the UK. Now another thing, the other thing you need to know is the thicker the cable, the larger the fuse it tends to be. That's something they've written in the syllabus. They want you to know that if you've got a really thick cable, it's like to have a really big fuse in it. The other thing you need to know is that all the metal pipework in your house, the radiators, the plumbing, the taps, all systems that have got metalwork in a long system have to be something known as earth bonded, which basically means an earth wire is connected to each of those circuits, to each of those devices in several places, so that if you accidentally touched a live wire onto any of those metal devices, rather than cause all the radiators in the house and all the taps in the house to become live and possibly do some serious damage, perhaps kill someone, what would actually happen is the electricity would race down the earth wire into the ground. And because that is an easy path to go along, the live wire, which of course always has a fuse in it, the fuse would blow. And then at that point, obviously there'd be no danger there. So that's known as earth bonding. And if you're at home, you'll tend to see earth bonding behind the toilets, underneath the sink, for example. It's a green and yellow wire. And that is everything you need to know about fuses and circuit breakers.